So the last video we talked about the atom, the structure of the atom and the particles that make it, including subatomic particles and particles even smaller than that. We also talked about the fundamental forces of physics which actually hold the atom together and change the atom over time. Now in this video we're going to talk about some of the properties of atoms which actually make atoms do what they do. The first thing that you have to know about atoms is that in order to classify the atom you have to look at what we call the atomic number. Now the atomic number is usually listed on the top left corner of the symbol in the periodic table, as you see it down here. Some periodic tables will also put the atomic weight, things like oxidation states, the electron configuration, which we'll talk about later, the density of the atom. We'll talk about the melting point, the boiling point. But that will depend on how good your periodic table is. But every single periodic table will have 2 or 3 pieces of data. It will have the name of the atom, the symbol for the atom, which is usually an abbreviation for that, and then you're going to have the atomic number on the top, and you're going to have the atomic mass. Sometimes the atomic mass is up there, sometimes the atomic mass is down here. But either way, that's what you got. So let's talk first about the idea of atomic number. Now, the atomic number is basically how many protons the atom has, because the major difference between atoms is going to be the number of protons it has. The smallest atom known to man is the hydrogen atom. All it is a proton surrounded by an electron. So this atomic number, therefore, is 1. Is atom number 1. Is all the way to the top left of the periodic table, and is number 1. Now, an atom that has an atomic number of 64 will have 64 protons. So that's basically what determines the element that the atom is. Each element has its own atomic number. In other words, if my atomic number is 14 and somebody else's atomic number is 15, I know that that is not the same element as the first one. The number of protons determines the element that the atom is. So an element is a specific type of atom, or in other words, an atom with a specific number of atomic number, which means a specific number of protons. What that tells us basically is a lot of stuff about the atom. For starters, that will help determine the physical properties of the atom. Remember this, the atomic number determines the physical properties of the atom. It will determine how the atom looks like, it will determine what the atom smells like, everything that's listed up top on the lecture guide about the different types of physical characteristics, things that you can change and observe without changing the element itself. All of those things will be called physical properties of the element. Depending on your atomic number, you're going to be a different element, okay? And that's going to determine the way you look like and who you are basically as an atom. Now, there's also the concept, the atomic mass number. So if you add the total number of protons and the total number of neutrons of an atom, you get the total mass number. Now, for example, a carbon atom that has 6 protons and 6 neutrons, atomic mass number of 12. What that tells us is basically how many protons and neutrons that atom has. Because if we know that the atomic number is 6, and then you know that the atomic mass number is 12, you know that this atom must have 6 neutrons, because it's 6 protons and the total is going to be 12. So if I say an atom has 8 protons, that's its atomic number, right? And I say it's got 9 neutrons, what's the mass number? The mass number is going to be 17. And so forth. Now, usually the number of neutrons closely matches the number of protons, because you will usually need 1 policeman to separate each proton from each other. Now, as the atoms get bigger, it's not going to be enough to have just 1 neutron per proton. You're going to need more extra neutrons to try to hold that atom together. And even then, those atoms will tend to be unstable and decay. We'll talk about that in the next videos or so. But remember this, the mass number, atomic mass number, is the number of neutrons plus protons. Now, when it comes to the atomic mass number, you ignore the electrons. Normally, the number of protons and number of electrons is the same. So if I tell the atomic number is 8, that means I have 8 protons. Normally, that also means I have 8 electrons. Why? Because if you have 8 protons, that means you have 8 positive charges. And if you have 8 electrons, that means you have 8 negative charges. So overall, the charge is 0. The overall charge of the atom is 0. The atom has no charge. Okay? It only has a charge if it's either missing an electron or has an extra electron. And that will happen in certain circumstances, which we'll talk about later in the lecture series. But if the atom is in its natural state, the way it shows up in nature, it will have the same number of protons as the number of electrons if it's on its natural state. So just to practice, I tell it an atom has an atomic number of 9. That means it has how many neutrons? How many protons? Well, you can't tell the neutrons unless you get the atomic mass number as well. So I'm going to say it's got a mass number of 20. Okay? So that's my atomic number, and that's my atomic mass number. All right? So 9 protons, atomic number, means it has 9 protons. If it's on its natural state, it's also got 9 protons. And since the atomic mass number is the protons plus the neutrons, the difference is going to be the neutrons here, so it's going to have 11 neutrons. Notice, though, that you ignore the electrons when calculating the atomic mass number. That's because we talked about the electrons are so tiny that their mass is negligible. It will take literally almost 2,000 of electrons to match the weight of one single neutron or proton. And so you don't count them. There's also the idea of the atomic mass. And you see that here. It's called the atomic weight sometimes. Just to differentiate between atomic mass number and atomic mass. Some people refer to it as atomic weight, just to make it less confusing. But the atomic weight is measured in a special unit called AMU, which is called atomic mass unit. Now, each AMU, one AMU, okay, equals to the mass of a carbon atom divided by 12. So if you get the mass of a standard carbon atom and you divide that by 12, that equals 1 AMU. That's just how you set it up. You needed to create a new unit for mass of the atom because grams, or it was not enough. The mass of the atom is even smaller than picograms, which is billions of times smaller than a gram. So the atom barely weighs anything. And so you needed a special unit just for that. And so we used 1 AMUs. Now the hydrogen atom, for example, has an atomic weight of 1.0 something. I think it's 1.003 or 007. And you can just look at the periodic table to confirm that. But either way, why is it not exactly 1? Because remember that the hydrogen atom typically only has 1 proton and 1 electron. But I'm telling you, I'm going to ignore the electrons. So how come the atomic mass weight is now 1? Okay? Because think about it. How many protons does carbon have? Carbon has 6 protons. It also has 6 neutrons. So 6 plus 6 equals 12, which means 12 divided by 12 equals 1, right? So 1 AMU should be the equivalent of one of those atomic particles, 1 proton or 1 neutron. So the hydrogen should be 1, the atomic mass number. But it's not. You see, we're going to learn about it in the next video. But the thing is that there's a lot of different kinds of hydrogen. Now, every single hydrogen out there has 1 proton in it. But you can find hydrogens with extra neutrons in it. And that means there's different kinds of hydrogen. So to get the atomic weight of hydrogen, you get to get the mass of each of the kinds of hydrogen that exists and do a weighted average for that. And we'll talk about that after we do the talk about isotopes. But just remember this. The atomic mass, not the actual mass of an atom, is the average mass of that type of element. And if you have multiple versions of that element in nature, you have to get the average of all those versions and have to actually get the atomic mass or the atomic weight, whatever you call it. But remember, you do not count the electrons because they have negligible mass. It's just protons plus neutrons which determines that. And the atomic mass number is an integer number that refers to the total number of protons plus neutrons. The atomic mass refers to the actual average mass of the type of element as seen in nature. On our next video, we're going to talk about those different kinds of elements that time shows up and how we can actually use them in science. See you guys then.